This question is asking us about our knowledge of systems of equations as well as how exponential and logarithmic functions relate, which they are inverse functions of each other. So let's take a look. Which of the following values is the x-coordinate of the point in the standard xy coordinate plane where the graph of the function y equals natural log of x minus 3 plus 4 intersects the line y equals 9? Sometimes this gets read as ln x minus 3, but ln stands for natural logarithm. So we have a few options. You could graph this on a calculator, a graphing calculator, graph that on a graphing calculator, see where those points intersect, and then determine which one of these values corresponds to that point. There's a few different ways we could do this algebraically as well. I'm going to just show it where we plug in the value y equals 9 into this equation. So when does this equal 9 would look like the following. 9 is equal to natural log of x minus 3 plus 4. Okay, so just like most equations, we're trying to solve for the x coordinate, or just get x alone. So let's undo everything that's being done to x. So the first thing, maybe the most obvious, is just to subtract 4 from both sides of the equation. That would leave us with 9 minus 4 is 5 on the left side, and then just the natural log of x minus 3 on the right side. Okay, this part, again, we have a few options here, but what this is saying is it's the natural log of x minus 3. The x minus 3 is within the function. So the next thing we need to do is to undo, do the opposite of, do the inverse of this function to solve for x. So this is the natural logarithm. What that actually is, natural log is a logarithm with a base of e. And e is an irrational number similar to pi, but it's a special logarithm with base e, and that becomes the natural logarithm. So for that reason, what we're going to do is we're going to undo the natural logarithm by exponentiating both sides with the base of e. And that's kind of a different word, but it helps us see our answer here. So what I do to one side, I have to do the other. So I'm going to do e raised to the left side, which is 5, and e raised to my right side, which is natural log of x minus 3. Okay, this could be a number if we put that into a calculator, but let's just leave it as e to the 5th power. And then what happens here is an exponent raised to its logarithm of the same base will just become the argument, which is that piece there. So the e and the natural log, they're inverse functions of each other, so they undo each other, leaving us with just x minus 3 on the right side. Okay, our goal is to get the x-coordinate, to solve for x. So let's just now add 3 to both sides. All right, and this is e to the 5th power plus 3. So we just keep it that way because one's a exponential and then this is just a constant value. And that is equal to x. We now have x solved for by itself, and so x is equal to e to the 5th power plus 3, and we see that in answer B.